Hey, what's going on, guys? Command Kinsey here. By the time we are deciding which approach to take for this channel in future and actually turn it into this on-demand programming tutorials resource, absolutely free one, I decided to make this little video which serves the purpose of hopefully gaining for you guys a better understanding of my position in regards to how to code, how to learn, and how to learn to code, basically. So this might sound a little bit weird, and this, well, at least I've never seen any similar format on YouTube at the very least. So I'm not sure whether you like it or not, but I have an absolutely concrete thing I'd like to share with you guys in regards to the way how the code actually might be written, the reasons and the circumstances behind why that is actually the case, and what kind of purposes does the certain type, does the certain way of how the code is written actually serving. So it's very important to, when you're writing the code, it's incredibly important to realize what is the goal of this code. So apart from just getting the job done, obviously, apart from like all the programming is about the problem solving, right? But when you encounter a problem, apart from just solving the problem, usually this problem relies within a certain context, and this context is very important because this context actually defines the programming job you might potentially be involved into. And what is even more interesting that the way you have obtained a certain skill might be compatible or might not be compatible with a certain kind of niche you're trying to apply this skill within. So it might happen that you can do something, but the way how you're doing something is not applicable to a certain niche. I don't want to go into the philosophical part of this because it just takes ages and probably no one would really understand what am I talking about. Not because you can't, but because probably my explanations would be too vague. So instead, I just want to provide you 1, 2, 3, 4, 5, 6 pieces of source code, 6 examples of different source codes that literally do the same. All the source codes are chess engines, and it doesn't matter in this case, like it doesn't matter that these are the chess engines basically. So this could be whatever. What I want to emphasize your attention at is what are the ideas these open source chess engines are written with. So what were the ideas that like why these chess engines were written, the reasons why exactly. You might be wondering, like, okay, the purpose of a chess engine is to play chess, but there is a whole lot of different sub goals, let's say, that could be considered, and depending on those sub goals, the style of code, the way how the code is organized varies significantly. And another extremely important thing is the following. So when we are about to be comparing something, whatever, doesn't matter, we really need to agree on a parameter we're going to be comparing this various sources by. So we're going to be comparing these engines by the parameter of how understandable the code is in terms of when you walk through the code, can you actually say after how the chess engine works. So here in particular, we are not trying to the idea is trying to catch the very gist of, like, the gist essence of what the program is doing as soon as possible. So that's the major goal. So we're not talking about speed, strength, and things like that. That's completely out of the scope of our interest in this video. So the only parameter that matters is how likely you would be aware of how chess engine is working after walking through these given examples of the open source chess engines. So it might still be a little bit vague. I mean, you might be wondering, what the heck is this and why am I talking about this? But I really hope that by the time I'll start explaining things, it would be more clear. And just to give you a little bit of the motivation why actually you might be interested in watching this, well, that's because this principle of being didactic that I'm trying to deliver, trying to explain, is the core thing and the only thing that actually helped me to learn all I know and allows me to still keep learning new things and picking them up absolutely from scratch. So like I've been answering to some of you guys in the commentaries in the previous video, like let's turn this channel into this on-demand programming resource. So like I said, my superpower is to pick up whatever topic from scratch and take this gist core essence from there and trying to deliver it in the most simplest possible way. And the price is sacrificing the best practices, sacrificing everything for the sake of understanding how this code works and why. So that's the core reason. When you have the understanding of what the code is doing, why is that doing it, so you can then divide and conquer. You can then apply your own principles, programming style, and so on. You can do whatever because you already have this unified understanding of the overall picture. Otherwise, if you're just going split it into the details, you might just get lost there, and you either need courses, guardians, whatever that would actually try to manage all this chaos that is overwhelming your mind, basically. So hopefully this brings a little bit more sense to what I'm going to be talking. So a bit of a more context. So what is a chess engine? And I'm talking about chess engines because that is something I put time and effort into. I've been doing chess programming for about 5 years, so I know something about this. So hopefully this is just a good enough example. But you just need to bear in mind that you can take like big data processing, machine learning, web development, whatever niche, web scraping even, whatever niche, and the styles of code, the ideas that developer has in mind when he's writing the code are all absolutely the same, no matter what the code does. So I'm talking about the chess engine, but this could be like, I don't know, like web framework, for instance, or machine learning framework, or like some online real-time data processing system, or whatever, really whatever. So chess engine is just something that I'm confident in order to point out this particular difference. But if you understand what I'm talking about, you would be able to see this difference in whatever code doing anything, because no matter what the code does, this sort of additional wrappers around the code actually defining this context, defining this environment within where this code is created within. And sometimes when it's the matter of landing the job in particular, it's the matter of whether this sort of a context is applicable for you or not, whether you agree to work within this context or not, and so on. And sometimes it happens that without actually understanding the overall essence of what the app you're developing is doing, you might be already forced dive into the context and like break yourself trying to get used to it, and then it turns out that it's not really the field of your interest completely, and then you just drop, and then you're just angry because you lost lots of time, and you could avoid that, because if they just explain you at first like what is this thing all about, you would just say, okay, so that's not something I'm interested in, and you just quit, right? But when they don't explain you what's the gist essence, and when they're trying to dive into the context, it often results in being unsatisfied at early. So bearing this sort of things in mind, without further ado, let's actually dive into the source code. So we'll start by the world's, well, I'm not sure whether Stockfish is currently the world's strongest engine or not. Maybe Lily's are already beat it. I'm not sure, but let's say one of the most world's strongest chess engines. And it's also being described as the world-class chess engine, as the top level chess engine. So best practices, best programming languages, best development environment, everything freaking best is about Stockfish. And just to give you an idea, so the very first thing, so let's say you don't care about all these best things, but you just have a question how Chess Engine works. And a little spoiler, so Chess Engine is the program that takes board position as an input and gives the best move as an output. That's the simplest possible explanation of what the Chess Engine literally is. Just a single function, literally a single function that just like a black box. It takes the board position as an input and then it returns the best move as the output. That's pretty much all about it. That's all we can say about the Chess Engine. And now the difference between different Chess Engines is how likely the particular program is going to be solving this. So what steps to break this process into and so on. But the gist essence, you just take the board position and you just output the best move, input and output. That's it. So you don't know this, you might not be aware of this, but let's say you are aware of this. And now you just open the source code for Stockfish and you're just trying to figure out how on earth is this principle actually being applied in the real world piece of code. And the very first issue you would be encountering is the whole lot of files that you have no idea which one to kickstart with. And I just give you a little tip. So as far as chess program is about like taking board position, so we need some sort of to find a file where the board position is actually being initialized, defined, right? So in Stockfish we have this file called position cpp. Here it is. So and again, like when I first realized that this is the exact file, it really I need to walk through all of the files, even though I knew what I was looking for. And in general, in that case, at that time, already kind of did a general idea of how Stockfish works. But yeah, the problem is that even to find where to start looking for is already a challenge because so many files. And this is another best practice, right? So it's really like something that probably should be like in the perfect world. But if this is in the perfect world, then why the world we're living in is so horrible, right? So that's another question to think about. But anyway, so here we have this position.cpp, and the very first thing comes here. You see like this namespace Zobrist, and you like if you're not aware like what is this, you might get confused. Just right straight ahead from this point. But well, for instance, this Zobrist is the last name of the guy who has created the Zobrist hashing algorithm. So the idea is to assign a pseudo-unique number to every position in chess, and that serves many purposes. First of all, for instance, like detecting the threefold repetitions, and also it allows to use a transposition table, which saves the nodes that are searched within the search tree just in order to avoid researching the nodes again when you already have the results for those nodes. Okay, so scrolling down a little bit more, and we can see that probably this looks like a routine to print the board, right? It looks like that because we look over ranks, over the files. But here we start encountering something that if you're not familiar with C++, and even if you are familiar with the object-oriented approach, then already it's really hard to understand what the heck is going on here, because you see some syntax that you might not be aware of, and well, so if you know that this is the format of like the object-oriented calls for like in Python this would be like class name dot method. So in C++ they use this double colons here. So yeah, we see that we have in the pointer the position, but some sort of a stream here, and you just getting overwhelmed like what the heck is going on here. Like you see that the idea is very simple, so eventually you need to print a board. It's literally just to print a string to console. But all of this stuff, like, oh my god, what the heck is that? So it's really like those layers, if it's an onion-like structure. So you have the core, which does the thing, and then you have a whole lot of things of layers being wrapped on top of that, and you're just getting confused, and this doesn't bring you to understanding how the chess program works. It starts making you thinking like, okay, I need to learn the object, I need to learn C++, I need to learn what they've changed in the C++, like 17, 19, whatever else they have. And you just go in completely different direction. You need to figure out how the streams works in C++ and so on. So you would start doing anything but trying to realize how the chess program works, right? So that's the core thing I wanted to emphasize here. So it looks very solid, it looks world class, it's just super cool, and something that everyone should be, as they claim, everyone should be like following this. And if you can write a code like this, then this is epic, and definitely like you would be happy if you can write the code like this. But does this sort of a code actually user friendly? Is it beginner friendly? So if you barely know how to code, if you know just some basic principles, would you be able to read through this source code and to understand something? And I'm not even talking about understanding how the chess program works itself, because that's completely unclear in Stockfish at very least. So it took me several years to get near to understanding like how this overall spaceship is actually working. I then did realize that, and this might be described for a long time, but it doesn't make sense in regards to this video in particular. But anyway, so the question like how the chess engine is working is not answered completely. So going further on, and finally we have position class. Okay, so initializing routine. So we can understand something here, maybe. Then we have some commentaries. Okay, so set initializes the position object with the given FEN string. Fantastic. But then we think like, okay, this is cool. So what does this method actually takes as an argument? Okay, so it takes the FEN string as the string type. Okay, it takes the flag of is this the chess 960 or not? This is clear. Okay, thread. For those who is not aware how the multi-threading works in C++, this is like me, for instance. This is total gibberish. Like, what the heck is that? But yeah, you then may learn that the certain given operation might be executed within a certain thread. So that's kind of okay. And in this case, you can just split the search within multiple threads to increase the overall performance. Okay, let it be there. Okay, because Stockfish is the world's strongest engine. That's okay. But then you have a look at this, like state info, and you're like, oh my god, what the heck is that? And you just, where should I even start looking for this state info? And then you just, if I got already like how the chess engine works, your initial goal, you're starting looking for, okay, what is the state info? And you're still scrolling down, and oh my god, and again the state info, and again and again, and maybe you're lucky to find this one day, maybe not. But you see, like, the more you try to dive into the source code, the further away you're finding yourself further away from the original goal of understanding how the chess engine works. And here, obviously, we need to mention the major thing. Stockfish is not a didactic engine. Stockfish is something completely opposite to being didactic. So it doesn't have a goal of being like beginner friendly, user friendly, easy to understand, easy to contribute. They do claim that yes, we do update our code base, and I need to admit that the Stockfish, let's say 3 years ago, it was much worse. So now you can just try to read something there. Well, maybe my coding skills just got a little bit better. It's hard to say, but generally I think that Stockfish's source code has been cleaned up a little bit through the years, and I'm not really criticizing the Stockfish's code. I'm just talking about it from the perspective of if you're a noob, right, and you just want to know how the chess engine works, and you have a look at this code, you're thinking like, okay, this is the world's strongest chess engine, so this must be super cool. So if I understand like how it works, I will write another Stockfish, and it would be so cool. But nope, you don't even understand like anything at all, how the chess engine is actually operating, how it works. You won't have that understanding completely. And on top of that, It just involves a whole lot of complicated structures that you can barely understand what's the purpose of having those. And I need to say that this position CPP is the simplest file within the entire Stockfish source code. So if you have a look at the search, for instance, or at the evaluation, even before the neural efficiently updatable neural networks has been introduced, that's even worth there, because there that just complete, like, looks like a complete gibberish if you are not a pro, right? And we're talking about beginners. We're talking about just trying to figure out how chess engines are working. So this is the pole, let's say. So one side, one pole, and then we'll go to the opposite pole, to a completely didactic program, right? But just to bear in mind that we are comparing different source codes that do essentially the same thing, but with a different goals, in mind. Okay, so I hope it's clear in regards to Stockfish. So, well, probably one more thing I would like to show as well, which is, you might be wondering, like, okay, so it's a rocket science, forget that, but how can I compile it, right? And then the most natural thing is trying to have a look at the makefile. And when you're looking at the makefile and like and you just close this. Okay, forget that, forget the makefile. So that's my personal reaction when I first encountered this back in the day. So it doesn't help you to realize the gist essence of how this certain sort of software actually works. So it's really bad for that purposes. And why do I emphasize this so much? Because the vast majority of teaching resources, of those resources that do claim that they will teach you something, they do start from this Stockfish, more or less. But why they start from this Stockfish-like stuff? Because instead of emphasizing the general overall, just what you're gonna be doing, actually, they try to teach you to obtain these layers to be best practices, didactic, and best practices like production code, all this crap. I'm sorry, but for me it's really crap, because that's something that really puts you away from the understanding of the gist. I'm sorry for this personal opinion, but I just couldn't hold myself. I'm sorry, guys. So yeah, hope that makes sense. Now let's go further on. So back in the day, Stockfish has been the strongest engine for quite a bit of time. And back in the day, before introduction of didactic engines, there was a need, and it's not only my kind of complaints, right? So like the entire chess programming community actually wouldn't exist if didactic chess engines wouldn't exist either. So the world needed some sort of a simplified code that would not be as strong as Stockfish, because this is always a trade-off. The more simple code, the more easy to understand code you have, the less features, the less functionality, and in case of chess engines, the less performance it has, because you're just simplifying things, you're getting rid of things that are not essential to understand this gist, and that results in dropping of the performance and the playing strength. So yeah, that's the trade-off. You need to bear this in mind as well. So another engine we're gonna have a look at is Fruit, and don't get fooled by the fact it goes within my repository. I'm not at any point not the author of this engine. I just have this didactic engines folder where I've been collecting some didactic engines I learned something from. So yeah, just to give you an idea. So if we have a look at the overall project structure, you see like it has actually even more files than the Stockfish does. Yeah, the problem is that I was compiling and I forgot to add this object files to get ignored. So this is my bad. But anyway, it still has a whole lot of files, and it's still really hard to try to figure out, trying to understand like where to start looking at and how this works. But another little present. So if you have a look at this board, CPP which is exactly the same file like for position CPP that we just had a look at Stockfish. So this file does also contain the definitions of the board position overall and all the data structures that engine is using in order to operate, right? And here it's already slightly better because back in the day, Fruit was considered didactic engine at some point, and it actually gave birth to many engines back in the day, like Ripka, for instance. And it's really important that the Fruit was a sort of a compromise between this rocket science being introduced in the Stockfish and some like you can treat Fruit as the simplest professional engine. I would classify it like the simplest professional engine. So it's still like it's not world class already. It's much weaker, but at some point it's professional engine. So it's not a hobby engine. It's really professional engine, and it was quite strong back in the day. But meanwhile, the source code of Fruit is way more user-friendly because the way how the source code was written, I'm not sure, Fabian Lido Z, if I'm not mistaken, I probably pronounced the guy's name horribly wrong. So I guess he had in mind this ideas to share this with the community to give a sort of a highway of how to develop chess programs. So that was a period of time back in the day. So when Fruit was really like the mainstream at some sort, mainstream in terms of like how would you like to organize source code for your engine back in the day. So that was a sort of a de facto standard. Okay. And despite the fact it's actually this is not the original code. It's rewritten by some other guys, but they actually did emphasize this original style. And Fruit is really known for its style, which is treated to be didactic. I disagree with that because Fruit is still a rocket science. If you're a noob, it's not really easy to. It still doesn't answer the question how the chess program works, right? And still has lots of files, and it's much easier to read through the code. It's much easier to understand what's going on. The variable names and the method names are more meaningful than in Stockfish. And what I love the most within the source code, that despite the fact it's been written in C++, it actually doesn't use this damped object-oriented approach. And just to give you an idea, it's arguable when to use object-oriented approach and when not to use, and probably when we come to using the global variables, which I really love. We'll probably talk about this later. So but the time is just enough to say that here, despite being C++, it doesn't have this object-oriented stuff. It's just a pure procedural approach. So we have the function definitions, and the code itself, even though not lots of commentaries, it's really clear. For instance, if we have this, so in Stockfish, you remember we have this the board, the position, structure, and also the state. So it was separated into two, and when it comes to incremental updates, while during make move and unmake move, it just gets completely overwhelming. I didn't even show you that because they're just horrible. In Fruit, it's much easier. So we only have the board structure, the only structure, and this board structure already contains all the data sets, like the board positions, like in peasant, capture, square, castling rights, all the stuff the engine actually needs, like some additional structures like major pieces, minor pieces, and so on. And all this stuff is getting incremental updated to increase the performance of the evaluation mostly. But it's already much easier because the entire data that is being incrementally updated back and forth now actually relies within the only single structure, which makes it much easier, and it definitely makes it more didactic to walk through the source code, trying to understand it, and so on. So that's Fruit, right? And if you have a look at the source code, you probably just fill it like you see, like it's really, you have this board, and within the board you have this all of the parameters, all of the fields that you can access. So it's really more eye pleasing in terms of, you start feeling like, well, if you have a look at the source code of the Stockfish, you would most likely feel like chess programming is too complicated, it's not for me, and just drop that and try something else. When you're looking at Fruit, you start to feel like, oh, chess programming is really interesting, so I'm really excited and I want to try it on my own. So these are two completely different reactions that source codes that essentially do the same thing, actually invoking within the human that actually is inspecting the source code. So that makes sense. And yeah, also it's a well-known fact that Fruit is known for its never-ending asserts. So in chess programming, there is a whole lot of opportunities to produce bugs. And if you're not sure what you're doing, and if you're doing this for the first time, if you're not following someone's tutorial, you're just trying to pick this up from scratch, then you really need this asserts. And again, like Fruit has introduced these de facto standards for asserts, and all the engines that went after it actually were involving this assertations, and that's really cool. So yeah, when you just look at this code, it really feels like it's welcoming you. This code kind of tells you, please read me, please explore me, please try, like, here I am, here is how I operate. So the Fruit itself is a relatively complicated engine, but the way it's written for its complexity is definitely the simplest possible way, like the most a very complicated stuff that is presented in a really user-friendly, in a really didactic way, and at its time, and at its state of how strong it is, how capable it is. I believe that still Fruit is the best didactic, probably Fruit is the strongest didactic engine, if we can classify it like that. So probably let's call it the strongest didactic engine, because like I said before, it's always a trade-off. The more didactic your code is, the more you sacrifice some performance-related things. And in chess programming in particular, in most cases, the matter of gaining more performance very often results in an ugly code, and when they just trying to wrap that ugly code into this seemingly beautiful, like object-oriented thing, it really gets messed up completely, and it's really hard to figure out what's going on there if someone is not guiding you through that, and if you don't have a prior experience in chess programming, it's incredibly difficult to actually understand at least something from there. Okay, so this was Fruit, and let's have a look at the makefile as well. So here, it's still quite not one line, right? But it's less, and well, generally you see, like, okay, we got the objects, we have the executable, we just want to compile all of this. We have some optimization, so the makefile is really more like user-friendly, and it's really easier to work with it, to operate with it, because yeah, it just well, you might be wondering, yeah, it doesn't support like ARM platform, or it doesn't support like tons of other platforms or whatever. You just can compile it only with this, like only with GCC. You can compile with someone else or something. Doesn't matter. But anyway, even this makefile is less in size, and it's really more clear, and it's really more friendly, so you can at least try to understand something from this. So I hope this is clear. And now the next engine we're going to be having a look at is known as TSCP, and TSCP is Tom Kerrigan's simple chess program. That's the abbreviation. So TSCP is just another legend. It was written not in 2019, definitely in 1997, if I'm not mistaken. And it's nice to read that TCP is intended for people who want to learn about chess programming. So when they did Fruit, it was like, okay, we want to make a strong engine, but meanwhile we want people to understand how it works. So the emphasis is still strength and performance. But with the TSCP, Tom Kerrigan initially wanted to create an engine that people who want to learn about chess programming. So the goal is already shifted, and the difference in the illustrant between the fruit and the TSCP is significant. So I'm not sure how strong exactly fruit is, but that's definitely somewhere above 2200s LO, while TSCP is somewhere around 1700s, depending on hardware, obviously. But anyway, so 1600s, 1700s, no more than 1800s. Yeah, no more than 1800s LO points for TSCP. And the number of features that has been involved within the TSCP is incomparably smaller as opposed to fruit, let's say. So it doesn't have any threads, any like all these nitty-gritty things. So it's relatively simple, and it implements really the bare minimum alpha beta engine possible. And if we have a look at the code base, it's already much better, much easier to understand, because the number of source files is actually less. Okay, so let's have a look at exactly the same file, board.c, and now we have C. We no longer have C++, which is fantastic, because again, like C is much easier, and when you're writing in C, you're not getting distracted by the language, and you can more focus on what you're coding, basically. Well, I need to say that definitely in fruit, despite the fact that it was written in it was compiled with C++, but still, that's really a C-like style code. And I'm not sure, but maybe even the original fruit was actually written in C. I'm not sure. I need to check that out. Okay, so let's have a look at board.c at a TSCP. And here already, we see that we have just a set of simple functions. Well, a little bit of a downside that, unlike fruit, the variable names are not always that self-explanatory, not that meaningful. But we already see that, whoa, we have the produce and data h and data and devs.h. So we have only a few headers here, and we can already say like, okay, so let's go to, for instance, let's go for devs.h, right? So definitions, and we see like, okay, so we have some constants, uppercase letters. So far so good, fantastic. And now it gets really clear. Okay, so we have some macros to define the row and the column, extract the row and the column from the square. Okay, so far so good. What else? Now we have the structure, move bytes. Might not be sure what that does, but yeah, then we have the move. Okay, so move bytes is sort of it's actually this encodes the move. A more complicated ways to encode the move within the single integer, but using the structure results in the cars. And by the way, this is another didactic thing. So it's slower, definitely. It's around 30% slower, opposite to if you've been encoding this within a single integer. It's possible you just bitwise or the source square, for instance, with the integer, and then you right shift 7 bits, or how many, depending on the how big your board array is. Then you bitwise OR with the target square, and then you shift again. Then you bitwise OR with the promoted piece, if any. And here also uses the bits. Probably it's related to Caslin bits. I might be wrong, but doesn't matter really. And then they use this, so move bytes. Yeah, so and the move contains this move byte. So yeah, it's really getting more clear. And another structure. Okay, so yeah, still doesn't. It's not clear about where the board definition is. So let's go to data.h, for instance, and here we go. So color. So we have some array piece. I'm not sure, but probably piece is a word in TSCP. I might be wrong. I didn't have a look at the source code for quite a bit of time, so I don't remember exactly. But you just noticed one extremely important thing, that all these variables are, ta-da, they are global, right? And why? You might be wondering, that's the bad practice to use the global variables, and it's not good in general. But did you actually ask yourself why global variables are bad? In what context? And you know, like someone said that global variables are bad, but why? And I'm not going to be discussing this here in details, because it can take ages. But I just want to emphasize one really important thing in regards to chess programming in particular. So what is the core difference between having the global variables for all the structures that are needed within the engine, like the board position, like castling rights, impedance square, side to move, etc. So what's the reason to have them not as the global variables, but enclosed within a sort of a structure or in a class if this is C++ and object-oriented approach? Do you know why? Because of the multi-threading. So if you're using multi-threading, in that case, if you have the global variables, multi-threading is just not gonna be working because the threads would be conflicting with each other, and you just can't instantiate this sort of a board position or whatever. So when you're going for multi-threading, you need to instantiate your data structures, and in that case you need to create the instances either of a class or of a structure, and in that case you can perform operations on them, and then you need some sort of a system that would be compiling all the results all together, right? So that's another important thing. So if you're not going for multi-threading in your chess engine, and if you're writing a didactic chess engine, then definitely you're not going for multi-threading. And in this case, having this, like they did it in Freud or in Stockfish, having this data structures, structs, or even classes, like in C++, like in Stockfish, does not make any sense at all, because that just complicates the code. It complicates the reference of those referencing those structures, and it doesn't help user or beginner or programmer or whoever who tries to read this to understand how this works. And the global variables, on the other hand, they are way more self-explanatory, and it's really easier to track how those global variables are being touched, basically. And you might be wondering, like, this is bad to have a global variable because you can change this from wherever from the code, and you don't know how that goes. Well, in chess program, there are not so many places where you can change the internal data structures, and since they are not really that many places, you are okay to keep them in mind always, to just handle them, and that's just fine. So hopefully that makes sense. So it's really hard for me basically to imagine the situation when you can actually mess up with like updating the board array from somewhere unexpected place. That's not possible. So really, like, the chess program is a very sequential thing. It just goes like one operation after another, back and forth, and you always like going like din 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 like this. So you always see where you are, what are you doing, who is asking, who is referencing the structure, and this is easy to control, really. So from this regards, global variables are absolutely okay in chess, and since we're not going for multi-threading, and since didactic engines try to be the simplest possible, and bear in mind the fact that we need to understand how chess program actually works, so yeah, it's okay just to have this global variables. This is absolutely fine. So another thing I wanted to mention, and another thing I want to show in regards to TSCP. So the rest of files is also quite simple, and still the only problem with TSCP is that it's split into multiple files and not always meaningful variable names. And it's quite weak. That's another sort of an issue. But generally, apart from this, it's really perfect. Okay, but actually, when I just started and I had a look at the TSCP's code, I didn't understand literally anything there. So it wasn't helpful to me completely. So I was so noob that I actually needed something else, something even more didactic, because TSCP, after I realized that TSCP is brilliant, it's so easy, so simple. But back in the day, it was still rocket science. There was no much difference between TSCP, Fruit, and Stockfish for me back in the day. So its didactic value is still, even though it's intended to be didactic, still it's not didactic enough. So even a noob like me could have understood how it works back in the day. So one last thing, I just want to show you the makefile. And now here makefile is much better. Smaller, simpler, and just look at this. This is so neat, right? So you can see everything just works like a charm. So yeah, so very simple. Okay, so the next piece of code I want to share with you guys is absolute legend. So this is Vice Chess Engine by Blue Fever Software. His real name is Richard Tolbert, by the way, for those of you who's not aware of that. and he has a legendary series on programming a chess engine in C. And I've been following that series, and that's the series that actually made me start learning how to code in general. So I started from coding a chess engine. There was no things like Python, web scraping back in the day. I wasn't caring about that at all. So I started with chess programming, and I didn't actually want to learn to code. I just wanted to make a program that would be playing chess in my style. Yeah, that's fun. So yes, but it just turned out that I was kind of forced to learn C in order to write a chess program. That was a bit of a downside. I didn't want that, but I had no choice basically. But what is absolutely revolutionary for Vice by Richard Olbert is that, if we're not talking about his video series, which is just legendary, just absolutely fantastic, and he writes this code line by line, and that's the style that is just a forever style. That I took that style, and I've built my entire chess programming channel based on those concepts and principles that Richard Olbert has introduced. Back in the day, I just developed them a little bit more on the one hand, and on the other hand, I made them even more didactic because his code was still a little bit too complicated. Even though he was self-taught as well, like me, but still his code was a little bit more ambitious, I would say. And the more ambitious your code is, the harder to understand how it operates. So if we are talking from the influence perspective, then we can say that Vice is a mixture of fruit and TSCP, and that's the reason why I want to share this kind of thing with you guys here. So if we have a look at, same file, board.c, again, C, plain C, nothing else. But here, Richard Olbert does use the board structure to have all of the data. He doesn't use multi-threading here, but he's a sort of a perfectionist, and I respect that. And I don't see any particular reason doing it like this. For me personally, it's an overwhelming thing. Some complications arising with this structure referencing all of the time. In my engines, I was avoiding that, so I was doing like in TSCP using the global variables because of the reasons I have been explaining. I've explained already just a few moments ago. So generally, the way how Richard Olbert's code looks like, it's fruit. It's definitely fruit, and it's one of the greatest examples of, it's like this whole lot of assertions. This is so neat. So it's like a mini fruit, I would say. So it's a fruit in terms of its style, readability, understanding the variable names, very self-explanatory code, even though there is no single commentary here. But he was making this YouTube series, and you can't really observe this code separately from that series, because if you're watching the series, you're starting to understand how he does this, how he writes the code, and once you get his style, the code starts making perfect sense to you, and then you can read it easily. So on the one hand, we have this fruit-like style, like the appearance, the look of the code, the fruit-like look of the code, and on the other hand, we have TSCP simplicity. Well, this code is a little bit more complicated than TSCP. So TSCP doesn't have transposition tables, for instance. So Richard Olbert did the transposition table. He has a little bit more advanced search. He doesn't have that advanced evaluation though. So the evaluation in TSCP is a bit more complicated than in Vice. But anyway, this code is kind of the first ever piece of code that finally has answered my noob's question, how chess engine works. So looking through this code, watching that extremely big YouTube series, like more than 90 videos. I made 95 video series on chess programming myself, but it's not the case now. But when I walked through that, I did realize how exactly this magic happens. So you have a board position as an input, you put it into the engine, let's think it's a black box now, and then it just outputs the best move. How this happens, Vice video series, programming chess engine in C, answer these questions perfectly well. And the code also answers this question perfectly well. And I was highly, deeply, and incredibly inspired by many principles that Richard Olbert actually introduced in his engine, like the best from the best from a fruit in terms of code look, and the best from TCP in terms of being really simple. And even when he covers like more sophisticated topics, they still look really didactic, which is really awesome. So the first source code, and actually this motivated me to start learning C. And actually I learned C by just following this Programming Chess Engine in C series. So that's very important for the further understanding of my position in regards like the way how you learn things really forms the way how you can later apply those skills. So that's important, just to bear in mind. Okay, so the last two engines are those I've written. So we'll start by a little bit more advanced one, just to show later how I simplified this even more to finally answer this question, how the chess engine works. So that's what would be the cherry on the cake, right? So BBC stands for Bitboard Chess, and I have a 95 video series called Programming Bitboard Chess Engine in C. Just show you this link in the README file. It does have the distributed GUI. It runs on Python Anywhere server. And here are tutorials, and we have 95 YouTube video series, so it's really big. And yeah, now what I try to do in this project, I try to take the problem with Vice was it wasn't really that strong, but it's not even the matter of strength, it's the matter of how you can develop from there. So if you simply don't have enough features being implemented, then you need to implement them from scratch. If you don't know how, it's a little bit of an issue. So what I decided, the goal I set up for this project, and decided to take all the modern alphabet search optimizations available, many of those that are available in Stockfish as well, by the way. But I tried to provide the simplest possible, the most didactic implementation for those options, for those features, like razoring, even the transposition table was simplified a bit, is simplified a lot, like the whole lot of things. I just don't really want to dive into this now. And what I'm proud of, what I'm really proud of, so if we go to the source code, then ta-da, we have only one file. Okay. We have, so these are just 3 different versions. So actually, yeah, they're just one, every next is a little bit more advanced than the previous one. But generally, we have one single file, one source file. And you just can't ever imagine how helpful it is when you have the entire engine being in the single file. And I already see those discussions in the commentaries, like having the project split into multiple files makes it easier to maintain the project, and if it's maintained by many persons, and if it's modular, it's really easier to blah blah blah. Yes, I know that, but the goal for this is just to write it once, to answer the question how the Bitboard Chess Engine works, and that's it. No one is going to be maintaining that. It's a base. It's this core gist of the onion with the layers stripped. So you can just take this core and you can understand how it works, and then you can build whatever on top of that. And many guys did, by the way. So I even have 2 engines published. They are in the README, but much more guys actually did. They send me by email like their works based derived from BBC. So let's go to the source code. So here we don't have those files, and the goal of the project is here. So the engine is dedicated to hobby programmers, not to the professional programmers, to hobby programmers facing issues with reading code of the open source chess engines. That was exactly my case. So this goal is very important. The engine is incredibly easy to read and understand. It uses global variables everywhere it's possible. I do emphasize this. And sometimes even sacrifices performance for clarity. So sacrificing everything just to make it as simple as possible, as easy to understand as possible. And in terms of what does it consist of? So it's mostly based on Vice, but it uses global variables instead, and it adds for mode generator, it implements its own magic number generation. So there is a hashing technique called magic bit words. It's used in order to generate a text for sliding pieces, and this code is derived from Tord Romsted's code. Tord Romsted is the author of Stockfish, and he has a code snippet on Chess Programming Wiki, and that code snippet actually kind of strips the core of Stockfish, that is responsible for generating this slider piece of text. And that code was quite obfuscated, I would say. So I just simplified that. I added meaningful variable names for that, and I did make this entire user-friendly atmosphere. So this engine is about the atmosphere of the code. So let's have a look. You see, all the definitions are going on top. I'm explaining even things like putting the binary and decimal representations for those who might not be aware, how that works. For instance, we have the coordinates. Here just all the standard enumerations, right? Then when it comes to the bit boards themselves, so I do explain how many bit boards we have. So every diagram represents a bit board. This ones represent the type of piece for a certain given bit board. For white pieces, for black pieces, then for occupancy. So here we have all the white pieces, or here we have all the black pieces, here we have all the pieces on board, and all together we have eventually this board. So it's already starts getting clear, right? And again, obviously this should be read in the context of the 95 video series I made on YouTube covering this chess engine. And then the most fantastic thing I like is, so U64 is type unsigned long type array bit boards and 12. So this is actually the board representation. So this tiny little line. Then we have the occupancies, which are presented here, which is needed for the mode generation purposes. Side to move in peasant square, castle and rise, hash key, repetition table, repetition index, supply, and mostly that's it. That's all the data that you need for an engine to operate. So it's much more limited as opposed to what you have in Vice, in TCP, in Fruit, in Stockfish. So it's really bare minimum setup, but it works like a charm, right? Then some variables for timings. Well, it's they are grabbed from Vice, so I didn't want to reinvent the wheel where it didn't need to. And again, some functions from the Vice engine itself. You know that this style is completely different. So just have a look at this code, and you have a look at this code. It's different, right? So my brand new thing to command every line of code, which might be annoying in many cases, but still kind of works. So every meaningful variable names, every line of code is commanded. Every single step that is taken is commanded as well. The code sections are separated with the nice headers to give an idea how this works. The pseudo-random number generator, using this XOR shift algorithm I've grabbed from Wikipedia, and so on. The bit manipulation section to make this to not to rely on the hardware instructions that your processor might not even have if it's old and outdated like mine, but the pure software implementation, and so on and so on. Sorry. Then the Zobrist keys to obtain the unique numbers, and so on. The input and output, the print board function. That's simple. What else? Reset board, parse FEN to convert the FEN string. So, and this all does rely on the global variables. So it makes it really simple, really easy to understand. You can just take a variable, search for that variable, and you will find the variable definition just right in the same file. So it's incredibly simple and easy to actually walk through the different pieces of the code and see how they connect to each other. So this connection is the core idea of having the single file for the entire sort of a source. All right, so yeah, I can enjoy watching this code for a long time. So I hope it makes sense. Hope it's clear, but it still doesn't answer the question how chess engine works. So how can we take the board position as an input, and how can we output the best move as the output? So here I just want to give you an idea in terms of the size of the source code. So how many lines we have here? We have 4,681 line. Well, with a commentary, so it's somewhere, let's say 4,000 lines of code. That's somewhere around equal to the amount of code being involved within the device, I believe. Maybe it's a little bit bigger, but still, yeah. So still, it's quite huge. And now, my favorite one. So one of my latest projects. It's still quite outdated at the time, but still. So I call this engine Tyfish, and this is your first chess program. Didactic chess engine for absolute beginners in only 100 lines of Python code. I've been counting those lines for those purists. Yeah, so I've been counting those. And here, without further ado, I just want to dive straight ahead into the source code. Well, again, like usually I do prefer having like a single source file, but since I wanted to make it exactly 100 lines of code, I decided to split the data part, like the rules of chess, the data part, the data structures, not the data structures, but rather the initialization for those. I wanted to split this into separate files. So here we have the settings.json, right? And we have the certain FEN to initialize the initial position. Here are the direction move offsets for a move generator. Here we have the mappings of the piece types to the certain color. The piece weights for evaluating the material, piece square tables to give an engine an idea where to develop its pieces, specific second and seventh rank to distinguish the double pawn pushes and pawn promotions. The coordinates to easily look up and to easily convert the board square indices into this user-friendly coordinates, so it's to make it easier for user to see, to input the moves, and so the engine outputs the move not as the integers like the from square to square source and target, but like from E2 to E4. So the best move looks the best move is presented in algebraic notation, and this Unicode pieces to map the to make the pieces encoded pieces to Unicode characters, so that they were seen nicely like the chess pieces basically. So this helps user to see like not this letters like P for pawn, B for bishop, N for knight, and so on, but just to see this visual tiny little pictograms, just to make sure these are the chess pieces. So this is the data file, right? So 60 lines of code, but this is just purely data. And then this is something I'm really proud of. So this tyfish.py, and this is it. This is the entire chess program. It's incomparably weaker as opposed to let's say BBC engine that I made, or Vice or TCP. It's really weak. It doesn't have in peasant capturing, castling. It promotes to queen only, so it's really limited. And you might be wondering, yeah, it doesn't have the commentaries, but you need to agree that you can just read through the entire source code and understand quite easily what's going on there. Again, like I have a video series covering this in great details where I explain and talk about every single line of code in great details to give an idea how this works. So that's this source code is not intended to be studied like in separate from the video series. But even if you want to try to study this like separately, then we have, well, I did even make this a class wrapper here just for fun. Just trolling more, like I hate object-oriented programming, but I just made it for fun really, because in Python this is just fine. It's just a matter of the indentations basically, so nothing special really. So here, first of all, I'm initializing the internal variables of the engines from the settings.json file, and then the generate moves is the core riding horse of the entire engine. So it just makes and unmakes moves recursively, so that the engine can then evaluate every move to give it a score and to consider what is the best one. And here it's so simple. So we have a loop over the board squares. We do skip the overboard squares. Then we loop over the piece directions, like for pawns, like diagonally or upwards, for rooks, like orthogonally, for bishops, diagonally, for queens and kings, both. Then for sliding pieces, we also do an additional loop to loop over the attack ray, right? We have some additional exception rules for pawns, for double pawn pushes, to only capture diagonally, to only push forwards if no piece there, and double pawn push only if there is an empty space there, and only if you have the pawn on the 2nd or on the 7th rank. And because of the date encoding, well, we can do this quite pretty elegantly here. And yeah, this is it. And now finally, this code actually answers the simple questions. So we do take this FEN string as the board position. So we take this FEN string. So this is the input, right? And the output is, let's go here, let's go to Typefish. So the output is the search returns, it actually returns the best score. But meanwhile, we have the best source and the best target global variables, yes, and we do associate the best score with the best source and the best target score, which makes a best move in the current given position. So this search, what it does, it incrementally updates the board, so makes move, takes back, recursively calls itself until reaching the search depth, and if it reaches the search depth, it then calls the evaluate the position, right? And then the alpha, and it's not even the alphabet algorithm, just the brute force search one, just the enigmatic search. So if we found a better score, then we update the best score, we update the temporary best score, and eventually want to finally update the best score, the best source score, the best target score, to formulate the best move associated with the best score, and then we do that best move on board, and then there's a simple driver to play it. So yeah, we just asking the user to input a move, we do parse that move, we make it on the internal board, then we ask engine to search depth 3 here in particular, and then we make the engine move, and if this is checkmate, then we say it, and then we break out of this loop. That's pretty much all about it. So we had, I don't know, 5, right? 5 or how many? Stockfish, Fruit, TSCP, Vice, BBC, and Typefish. We had 6 engines. We have 6 source codes. Every of those was, so this is the summary, right? This is the summary. So we had 6 different source codes which do essentially the same thing. They do take the board position as an input and output the best move as an output. But the difference is that Stockfish is looking for being strong and looking for good performance, so looking to be the best ever in everything, right? But the price is that you have a look at the source code, you don't understand how it works, and you say like, okay, it's not for me, and just drop that, right? And Typefish is another like pole. So we said the one pole and another pole. So one pole and another pole. So another pole is, it's extremely miserable in terms of playing strength. It's really, I don't believe, probably like if it plays 1200 cello, that's great. Probably even less. I don't know. But it's really easy to understand. Well, the source code itself is really, I just didn't have the commentaries to make it exactly 100 lines of code, 100 lines of code. But really, this code is intended to be followed within the video series, and that video series is no longer 95 videos, but only 7 videos. That's just only 7 videos. So we have a look here. I don't even remember. Let's have a look. It should be somewhere around. We'll now start the advertisement. I don't want that.
It's going, guys.
Oh, actually, it doesn't.
Here, so.
Actually, it doesn't. What's a little bit strange? Where is the advertisement? Is this video getting monetized? Actually.
In this video, we'll define an engine class.
Yeah, that's a bit strange. Yeah, I need to check out whether Typefish is actually getting monetized. I was wondering why my monetization on chess program is so miserable. Okay, yeah, 7 videos, and then I made a sort of obfuscation of the source code, which already goes beyond the purposes of being didactic. But yeah, 7 videos is really less than 95 videos. You need to admit that. And then I made this so-called obfuscated version. So what I did there, I reduced the size of the source code even more. I dropped the meaningful variable names just for fun. So actually I made this to false into 1, and eventually here is my typefish mini.py, and this is the entire source code. This is the entire engine, 58 lines of code. And it does exactly the same what that big typefish with a class does. So here we already have these global variables, right? So we don't have classes. A little bit of a downside that they're not meaningful variable names, but essentially does exactly the same thing. So yeah, I really hope that I try to deliver the main thought within this video. So the main thought was that when you're trying to learn something, it's really important to, I believe, this is my personal opinion, I believe that it is important to sacrifice all these best practices for the sake of clarity and didacticness of some sort. So to be absolutely clear of what do you learn, why do you learn that, you need to be like hands-on thing, to get hands dirty, to get right straight away into whatever you're learning, in order to fill that, and in order to fill this unified sort of a thing, like all together. That's important. If you fill all the parts like united into a single concept that you are okay to understand, which is small enough to understand, which is clear enough to understand, in that case you can claim that you do master this piece, this skill, this program, this solving this certain task or something. And if I only had this typefish when I just started learning how to write a chess program, I would have been extremely happy, because I really felt the lack of this sort of a thing. Because you just imagine a simple scenario. So you're not sure if you're gonna be a chess programmer or not. So you just want to try some light version of chess programming, and bam, then you have TSCP, or bam, you have the Vice, and you just like, oh, 90 videos, oh man, how can I follow that? It's so, and you think like, maybe I shouldn't. So it's really hard to pick it up from scratch. It's really hard. But when you have this so-called light version, you sacrifice everything for the sake of clarity and being didactic. But in that case, you have this hands-on experience, and it's really getting clear what is this thing all about. And then you see a great room for optimizations. You understand why they split the data structures, why they don't make the engine as a single function, for instance, and so on and so on and so on. So you starting realizing like, where are those complications arising from. So we're talking from this onion perspective. So we have the core of the onion, then we have the layers, and when you have the understanding of this gist, then the layers that are going on top start making sense to you, and then it's already you to decide whether you agree to work within the context where those layers has been introduced or not. That's it from my side, guys. Thanks for watching. Looking for your feedbacks in the commentary. So if you have any questions or just want to ask what the heck was this, then please welcome. I would be happy to discuss this. So yeah, that's it from my side again. Thanks for watching. Until the next time, and take care.